Okay, so we're going to talk about eclipses. Eclipses happen when the Earth, the Sun, and the Moon all line up correctly. If the Moon is directly between the Sun and the Earth, we get a solar eclipse. If the Earth is directly between the Moon and the Sun, we get a lunar eclipse. Those are our two major types, solar and lunar. Within those, there are subtypes, and we'll talk about those. Um, Here's a great picture of a total lunar eclipse like we recently had. Every time a lunar eclipse happens, it's going to be at a full moon. Why? The moon has to be on the opposite side of the Earth from the sun in order to have an eclipse happen. And when the moon is on the opposite side of the Earth from the sun, it's at full. Now we can have a total lunar eclipse, we can have a partial lunar eclipse, or we can have a penumbral eclipse. And we'll show you what those different things look like. Here is a picture of a total eclipse, like the one we recently had. Here's a picture of a partial eclipse, and if you added up all these pictures of the moon, you can see the nice clear outline of the shadow of the Earth across them. All right. Now, the only reason this doesn't look reddish in here is because this the light here is so bright it washes out the reddish we would see there. All right. It's only once the the moon is completely in shadow that you get to see the reddish light. The Earth's shadow has two major parts, the umbra and the penumbra. The umbra is the part more directly behind the Earth, and it's this triangular shaped piece that is the fullest shadow that we have. All right. So when you draw a triangle from the sun over and like this, you can see that's all the geometry of the size of the sun and the size of the Earth dictates the penumbra and the umbra. So penumbra is dictated by the size of the sun with respect to the Earth. The umbra is dictated by the size of the sun with respect to the Earth. The moon is small enough to fit within the umbra, and so we can get total eclipses when it falls within the umbra. We get partial eclipses when part of it goes in the umbra, and then we get penumbral eclipses when it goes into the penumbra, and that's a dimming of the moon, not as dramatic as a total eclipse. You can see here also an illustration of what these different things look like. Penumbral eclipse is a dimming of the moon. It's only when it goes into the umbra that it turns this nice reddish color. Solar eclipses, when the moon becomes between the Earth and the sun, are a little different in that, mostly because the moon is a lot smaller than the Earth and is a whole lot smaller than the sun, right? This is a picture of a solar eclipse from space. So you can see it's daylight all around that, and it's only dark under that little patch that's the shadow of the moon on the Earth. Because of the geometry of the Earth and the sun and the moon, there's just a small, tiny patch on the Earth that ends up in total eclipse. Right? The rest, going north, south, and east and west, ends up in partial eclipse. So total eclipse has a path across the Earth, the ecliptic path. We'll look at a map of some of those from recent history. Um, that if you really want to see a good eclipse, you have to get into that path. Otherwise, you'll see a partial eclipse. I've seen one total eclipse. I've seen mostly partial eclipse, a number of partial eclipses. So total eclipse happens when the moon comes directly between you and the sun, right? And it looks like this. You can see the sun moving through the sky and passing behind the moon and out the other side. Um, they're pretty spectacular. And it's only at this point that it lasts for just a couple of minutes. An annular eclipse happens because the moon isn't always close enough to the Earth for it to be big enough in the sky to completely cover the sun. Sometimes because its Earth is elliptical, sometimes it's too far away, and when it's too far away, as you can see here, the size of the moon in the sky is smaller than the size of the sun in the sky. I've never seen an annular eclipse, but I would love to. All right, and quite beautiful. You have to remember to wear a protective eyewear and during an annular eclipse, just like any other eclipse, always wear protective eyewear when you're going to look at the sun because it is bright enough to make you blind. Partial eclipse happens way more often in terms of what we get to see or who gets to see it because partial eclipse covers a much bigger area of the Earth. I've seen a number of partial eclipses. You can watch. We had one here a couple of years ago. Nice partial eclipse. The full eclipse was up in the Nashville area. Um, when you have a partial eclipse, and if you pay attention to the light filtering down through trees and things like that, you'll often see the nice crescent sun on the ground because the leaves are acting like little pinhole cameras and giving you nice little images of the sun on the ground. This is a map of partial eclipses, and total eclipses. We got one coming up April 8th, 2024. It's going to pass near us. This one from 2017 was when I was talking about August 2017. You can see this is the path the shadow of the moon took across here. All right. That one, we got a good partial eclipse here. For this one, 2024, we'll have another good partial eclipse here. There are others I wouldn't mind going to see because they're occurring in nice places. We can go out to 2028 to Australia and watch that one. 2023 might catch a little bit on the west coast of Australia here. So there are other places where you can go to catch these eclipses. You have to know they're coming. You have to travel to catch the total eclipse. Most of us don't get that luxury. Most of us have to, deal with what we got. Here, August 12th, 2045, we're looking forward to an eclipse. That'll be good. So, the reason we don't have an eclipse every month is pretty simple. The moon's orbit around the Earth is tilted with respect to the ecliptic plane by 5 degrees. Right? And so we not only does the moon have to be between the Earth and the sun, but it has to be the position of the Earth and the moon and its orbit all have to line up so that the moon is not at its low point here, but the moon is in alignment in the ecliptic plane. All right. So eclipses happen because of all the relationships between these, and that's why you don't see it all the time. If the moon was in the ecliptic plane, right, we would have a solar eclipse and a lunar eclipse every month. Just like clockwork. Boom, 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 boom. Right? We don't have that because of this tilt. That doesn't happen that way, but there is a pattern to it. There's a pattern, and you can predict when they're going to happen. The Greeks, a long time ago, built an astronomical instrument to predict that. We'll talk about that at some point, the Antikythera device and its discovery. So just keep track of, you can look up at NASA's website when eclipses will happen. You can search for when eclipses will happen. And, of course, if there's going to be one and you happen to be in school here, we'll let people here know that it's going to happen. All right. Thank you very much. Don't forget to take your quiz.